Mr. Wagner is the team manager for the FHWA Pavement and Materials Technical Services team at the National Resource Center located in Atlanta, Georgia. His main area of expertise include implementation of asphalt technology and the mechanistic empirical pavement design guide. He has worked with all 50 states, all 50 highway agencies in the development, deployment, and adoption of these technologies. Chris earned a BS and an MS degree in civil engineering from Auburn University and is a licensed professional engineer in Alabama. Please welcome Chris Wagner.
Good afternoon. Like I said, I'm Chris Wagner from Atlanta. I'm from the Resource Center and Federal Highway Administration. I'm here to talk to you about high friction surface treatments. And this is the installation of high friction surface treatment in Rhode Island. And my other job, like was said, I teach a little bit, or I'm into mechanistic empirical pavement design. Now, it's much easier to talk about high friction surface treatment. I have a 13-year-old daughter, and when she says, "Dad, what do you do?" I don't start out with, we calculate stresses and strains in the asphalt pavement, look for the tensile stress and mechanistic properties, and put it through a transfer function to look at how that pavement's going to. Her eyes glaze over, right? She thinks I'm a real big engineering nerd. But when I talk to her about, I promote this thing called high friction surface treatment. That if you put this down on the roadway, you increase the friction of the roadway, and you keep cars on the paved surface instead of skidding off. She can really understand that. And I don't know if she thinks I'm cool. I don't think that's possible with a 13-year-old daughter, but she at least understands a little bit about what I do. In fact, I live in Kennesaw Mountain National Battlefield, near Atlanta, Georgia, in Marietta, Georgia, right outside a suburb of Atlanta. Last year, we had a car come into our area, and you kind of drive from kind of a congested area, and you get into this beautiful park. I'm lucky to live there. Well, this car came down into our park, and they kind of tend to speed up because it gets a little bit open. Came into there, got a bad curve, right? Got chevrons all on curve, slow down, downhill curve, not the greatest geometry in the world. Coming around that curve, kind of blind curve, it went off. It took out our beautiful brick entryway, right? Went off the road, skidded off. Took $17,000 our HOA paid to replace that brick entryway. 3 weeks ago, and I got to figure out who did this. It was the park or the GDOT. High friction surface treatment went in. I'm like, wow, that is awesome. Something I promote at a national level right here in front of my neighborhood. I told my daughter, look at this. Look, that's what I do. And yeah, her eyes glazed up. She's 13. Give me my iPhone, Dad. So here's the why. This is Marquette Interchange in Wisconsin. This is over 2 days. And you're just going to watch this. There's nothing, I can talk to you all day about geometry. We could put signage up, right? I bet you there's 30 chevrons on this curve. But there's nothing that makes an impact is seeing these vehicles come around this curve. A little bit wet, probably SSD conditions, surface saturated surface dry on the roadway, just a little bit wet. The geometry's not great. Downhill, and it's just bumper cars. This is 2 days. Now, what are the solutions to this? We sign it, right? That's going to work. Right? Put enough signs up there. Put some super on there. Now, this is an interchange, is like 4-level interchange. We're going to go redesign this, put some super on that roadway. You're going to make the curve wider. Right? How many billions of dollars right in the downtown area to do that? So what if we come up with a low-cost solution to fix this? This is just the traffic data. This is 3 years, 2 years and 10 months, and then on this side of the red line, 2 years and 11 months. So almost 3 years of data, 219 crashes in that 3 years. High friction surface treatment applied, boom. So this is like our gold standard of what you can do with this application. Okay, so that's immediate apparently why you want to consider high friction surface treatment, where you don't have other options to fix these run off the road crashes, these wet weather crashes. Looking at kind of a bigger program, not just one site. In Kentucky, what they saw was a crash reduction with their high friction surface treatment program. You know, we get huge numbers, 90%. These are ramps, curves, 80, 70, 80, 90% crash reduction in wet weather and in dry weather. So it's not only wet weather, but it's where you have bad geometry, short stopping distances, those type of things. Where should I use this stuff? Where should I use high friction? Anywhere where you can't fix it with other means, changing geometry, that sort of thing. Wet weather crash locations, your safety folks are now tuned into these locations where you have friction demand needs, high crash locations due to wet weather, curves, you don't have the right geometry on your curves, the speed, people like to speed into those curves. Intersections, you don't have enough stopping distance. Maybe you don't have enough sight distance coming into an intersection. People have to slam on the brakes. Anywhere you see skid marks on the pavement right before intersections, y'all know those intersections where you have a lot of black on the pavement, a lot of skid marks. What about those curves where you see a lot of rubbing on the rail, right? On the barrier rail. Just full of paint, full of tire marks on that barrier rail. That's maybe a place you want to consider high friction surface treatments. One big thing, this stuff costs quite a bit, $20 to $30 a square yard. So it's generally applied in short sections, quarter-mile sections. So it's a spot treatment for these locations. It's not an overall pavement surface treatment, spot treatment. And we'll talk about maybe some opportunities, some other surfaces we're looking at that might be applicable to the whole pavement surface. What is high friction surface treatment? Well, I have the two parts. I have a little, my wife's a kindergarten teacher. She calls this an activator. You pass it around, you touch it, people get involved with the subject. I've got the two parts are a calcite bauxite aggregate. Usually it comes from China. Okay, and then on the bottom here, you can dig in here and dig in here with this. This is a dynamic friction pad that we used, and you can see the epoxy down there. A two-part epoxy that is mixed in construction, put down on the pavement, and then the calcite bauxite is laid with a chip spreader or a blower. We'll show you both applications. There are other types of polymer binders that are used in high friction surface treatment. However, that's about 90% of them are this two-part epoxy. So we're just going to focus on that since we only have about 30 minutes today. Now, what's this epoxy material? Does anybody put two-part epoxy on your garage floor? I did it. You buy it at Home Depot. You mix the two cans and you lay it on the floor and it heats up. There's a chemical reaction that heats. You can feel it heat up. That's what this stuff is. Not exactly the same. There's all kinds of chemistry that goes into these polymers. This stuff was originally developed for bridge deck treatments. So as an application to concrete bridge deck treatments, now it's being applied to asphalt pavements. But anyway, it's two-part epoxy. Comes part A, part B. This is a automated, or this is a semi-automated installation where you have these pistons. So these pistons, you have a part A piston, and on the other side you have a part B pistons, and they draw the epoxy into this piston, and they have to get the right amount. In this case, it's 50-50 split between part A and part B. Usually they're 50-50 split, and then once those pistons draw enough material, they fire. So you make sure you get an accurate mixing of the material. I don't know if anybody's seen like the hand mixing. When this stuff originally started, there was a lot of hand mixing application, 5-gallon buckets. They're mixing it in drums. This is a little bit more sophisticated system, better application. Make sure you get the mixing rates correct and all that good stuff. So we put that epoxy on the pavement surface, thin layer, and we'll allow about 50% of the embedment of that chip into the pavement layer. So I'm passing around the calcite bauxite. This stuff, like I said, most of it comes from China, so it's fairly expensive aggregate. Bauxite is the same stuff that aluminum is made from. So you take this bauxite, it's like a clay material. Calcine mean is fired, so it's put into an oven and fired to a very high temperature, makes it very hard and very brittle. We tried a lot of different, the first thing, this stuff is expensive. Can I use some other aggregate? Can I use this process with some other aggregate? You cannot get, and we tried it, we tested, and I'll show you some results. We tested a bunch of different church slags, trap rock, flints, a lot of flints out there we've tried. You don't keep that high 65 plus friction number. So this is the gold standard, kind of that ultimate friction aggregate out there currently. Comes in super sacks. They ship it to you in super sacks. Let's see. Now here's a video. So here's the high friction surface treatment truck, the epoxy, and then we'll show you a video of it actually being installed. Oops, maybe. So it's about a walking speed application, maybe half walking speed application. Pretty quickly. You have this, let's go. These red nozzles or these red tubes are the friction or the epoxy coming into this mixing bar right here. Let's see if we can get this started again. There we go. So you think, oh, that's what it is. I'll use my finger. Here's I call it an octopus. There's an octopus that the epoxy is coming through these red tubes into this mixing bar. The bar actually has a mixer inside of it, so when it's forced through, the A and B gets mixed. And then you have the chip spreader in the back dropping a uniform chip application. This guy, he's probably just showing that he's useful by doing that. You know, kind of like the Luke guy on the asphalt paver. I need to be out here doing this. But you can see pretty even application with this as it drops off the rubber squeegee here. So you can change the application rate by changing the drop height of this squeegee. There's all kinds of controls on this. And then it comes immediately behind her with a chip spreader, dropping the calcite bauxite. And these guys are shoveling, just getting spots that I may miss. Like I said, sometimes maybe a little too active with the shoveling the aggregate, putting more than you need. But anyway, pretty quick application, and that's the automated process.
So Chris, what's the steam or whatever? Is that dust or is that steam of the hot epoxy?
Yeah, that's dust. So the epoxy gets hot almost to where if you grab that cup that I passed around, it's almost too hot to kind of keep your hand around, but it's not steaming hot.
Not steam, no.
Yeah, so that was dust on the aggregate. You don't want too much dust on that aggregate. So
Well, I was surprised that it was that dusty.
yeah.
Enough money for that stone.
Yeah, it's got a little dust on it. It may look probably a little bit more dusty than it actually is because it's kind of falling through that chip spreader. So it really is a fairly clean aggregate, but you do have a little bit of dust on it. Now we'll talk about you want to capture that stuff. So the stuff the extra aggregate that's on there, they have a vacuum sweeper that comes and captures it back up. And if you do that, if you use recaptured aggregate too much, it can get a little bit too dusty and break down a little bit as you recapture that aggregate. So like I said, why calcite bauxite? Why can't we use the locally available aggregate that we have? It'd be a lot cheaper. It's just you cannot get these super high friction numbers off the locally available aggregate. So we're talking about the gold standard using calcite bauxite with the epoxy. Question?
What about the dust itself and the impact to the workers?
I haven't seen any of the workers using dust mask or anything like that. I've been out there Now, I'm not standing right behind there like they were. I'm standing a little bit off taking pictures, but it maybe came a little bit off like it's a lot more dusty looking at that video than it really is. It really isn't, it isn't super bad out there. I haven't seen the workers wearing dust masks. As I said, you want to reclaim this aggregate because it is expensive, so they have vacuum sweeper, get all that aggregate off. It's not going to break windshields because, as you saw, it's a very small aggregate, but you do want to claim it just from cost perspective. Best practice is to mix the reclaimed with the new aggregate so that you get a mix. As this aggregate goes through the process, it does break down, get a little bit more dusty, so you do want to mix that in with the new stuff. This is the semi-automated installation. You can see this guy here with a blower. He's blowing the aggregate onto the surface. This is the epoxy they hand spread. Here's the wand. The epoxy comes out of a wand. Still have the pistons here mixing the epoxy, but he's hand applying with a wand, comes out, and these guys have a rake, a squeegee, a notched squeegee, and they're squeegee the epoxy on the surface. This is a much slower process. You also have guys here shoveling rock to make sure they get any surface that hasn't been covered completely. You can keep the stripes. You can tape inside the stripes and keep the stripes if you don't want to restripe the roadway, so that is a cost savings too. Some of the details. Here's the squeegee notched. Now you got to replace these squeegees because those notches will wear down as you go down the pavement. A little bit of an art too to get the proper film thickness. So you don't want to press down on that squeegee too much because that'll decrease the film thickness. So the automated process takes a little bit of the variation. The previous installation takes a little bit of variation away, and it's much faster than this process. Here's a finished surface from the asphalt pavement. You're not talking 1-2 chips thick, so a very thin application. This stuff, if you fall on it, has anybody rubbed their hands on this stuff? You will bleed. Yeah, question? Yeah, if you do fall on this stuff or you rub your hand, you will bleed. This stuff is very, very sharp, very angular. When it breaks, when this aggregate breaks, it doesn't polish. It actually breaks and reestablishes the friction, reestablishes the chip, the very high friction surface. So what Federal Highway is doing, we realize this costs a lot of money. What if we could come up with a cheaper alternative? Maybe we don't need that 70 friction number, that really, really high friction number. Are there materials out there that we can use that gets slightly lower friction, meets the friction demand, but you can do it over the whole surface of the roadway, you can do it at cheaper cost? So this is kind of the concept we're looking at. We need a friction capacity depending on your conditions out on the roadway, wet weather conditions, curves, those type of things. Do we need always that high friction surface treatment at that 65 or plus? Can we get by with something we're calling enhanced friction surface treatment? I'm going to talk about an asphalt-based alternative that we're looking at. Or you can do other surfaces like SMA or chip seal or something like that to establish friction. We have a study going on right now to kind of define this friction demand. How much friction do you need? So our safety folks are working on what conditions do you have out there where you really need what level of friction. So we are still yet to define this axis. We're working on that. That's really what we need. Right now we're saying we've got a great friction product, use it everywhere where you have crashes that require more friction, but we may be able to back off on that. We need to quantify that so we know how far we can back off. Like I said, we've placed a lot of these. Federal Highway has sponsored a lot of sections inside the curve. There's some on the east curve that Florida did, I think this 4th or 5th cycle. And then Federal Highway placed a lot of epoxy curves here in the curve. We did granite, we did chert, sandstone, flints, and bauxites. The bottom line is the bauxites performed over time. They definitely separated themselves from the local aggregate sources. So that's why the AASHTO specification calls out for calcite bauxite. We also placed this year, on this cycle of test track, we placed an asphalt-based enhanced friction treatment. What this is a micro slurry. Now the difference is this has a high polymer content emulsion. So a really high polymer content emulsion, and it has 50% calcite bauxite, what I'm calling the coarse fraction, +4 material. The same material I passed around there has 50% of that material in, and then 50% limestone. And then it also has some fine limestone in there to create a mastic for the microslurry. Microslurries need that mastic. So fine limestone, on the coarse fraction you have 50% limestone and 50% calcite bauxite. The idea is the limestone is going to polish away and expose that calcite bauxite and give you friction. I didn't know if it was going to work. When Mike Heitzman talked to me about this, I'm like, I don't know, that seems fishy. This is the finished surface, kind of hard to see. It's always hard taking pictures of asphalt, right? It's black surface, it's difficult. So just what I explained on the coarse fraction +4, 50% limestone, 50% calcite bauxite. It's a micro slurry, so very thin application. Fine fraction is limestone screens. You want to keep that mastic in there. The big deal is we need shear resistance. You're in a curve. You're going to have high shear friction with the tires. You need shear resistance. So what kind of binder can we use to get that shear resistance, prevent chip loss? High polymer modified emulsion. So here's the results. This is put down in September. We've got, about 6, 7, 8 months or so of data. This is the high friction epoxy calcite bauxite that was placed in 2011. So this has 10 million plus whatever's been put on it, 12, 15 million easels on it right now. So this has got more traffic on it, okay? I want to be fair. That was placed in 2011. This is our high friction calcite bauxite limestone mix placed in 2015. So right now, it's looking very good. You can see you're not going to get those very, very high friction numbers, but you're getting very, very good friction at a much reduced cost. We tried some sandstones in here just to see. It looks like the sandstone is polishing, coming off. Maybe not the best. It looks like the calcite bauxite really is the key to keeping that friction number. We're going to see how this plays out over time. If it stays flat, I'm going to be a happy guy. We reduced the cost from $20 to $30 a square yard to about $5 to $10 maybe dollars a square yard, and you're getting slightly reduced friction. And then we're going to start developing those. Where can we put this? Where do we need the gold standard? Where can we put this slightly lesser material? Over here is all those high friction surface treatments that were placed in 2011 with those granite, chert, sandstones. These are those sections here. You can see quite a bit less. Now these have 10 million easels plus on them, so there's a lot more traffic on there. But they don't hold up near as well as the calcite bauxite. Now what's the lifespan? This is kind of the totality of data over easels, easel range, okay? It's kind of hard to see, but let me break it down here. High friction bauxite epoxy are the blue and the red. So we got 35 million or so easels out of the high friction surface treatment epoxy. That was on the east curves on the Florida sections. It started to break down. What you saw is after 35 million easels is a lot. And that's over a lot of summers and winter cycles. Now it's Alabama winters, but a lot of traffic on here. You saw a steady from 60 to 65, so it retained its high friction properties over a long lifespan. It started to drop. This was hand applied epoxy, and what you saw was kind of some, you'd have strips of high friction aggregate still there, and then you'd have strips that had come up. It looked like maybe some hand application didn't go, well, it still lasted 30 million easels, but it seemed like some application issues of why that stuff kind of came up. You had a drop of friction reapplied to that section, and kind of the same curve established itself. Conventional aggregate epoxies, same polymer epoxy that we use, but with conventional aggregates, the cherts and the granites, lower friction numbers and more of a decline. You see these kind of steady decline in the 40s to 50s range. And then conventional dense graded asphalt. So always compare it to kind of conventional 12.5 millimeter super paved mixture. So you can see the difference from conventional asphalt and the different layers. So So what we're trying to develop is kind of this friction engineering toolbox at Federal Highway. How do we wrap in this pavement preservation concept to this? With the epoxy high friction surface treatment, there really is not really a pavement preservation concept because you're spot treating. Okay? With asphalt based, if you have a polymer modified micro slurry, you're gonna get a pavement preservation aspect to that. So we're gonna look at that with the stuff we're doing at NCAT and see how many years extend the life of that pavement. So you're getting kind of two things there. And then we have other things like a high friction thin lay. What kind of pavement preservation aspects can you get from that? And you also, what friction capacity do I need versus what costs? So there's a balancing act. And we're going to work, Federal Highway is working on what friction demand do you need. Can you apply some of these other treatments? How am I doing on time?
I got 5 minutes.
5 minutes, okay, perfect. Where are we with the state DOTs? The ones in blue, including Tennessee, has placed probably the most high friction surface treatments in the country, right here. Danny Lane, I didn't see him here. He's here at the conference, I saw him yesterday, but he's a big champion for high friction surface treatment. In fact, I brought an award for him because he's done such a good job. I wish he was here. I could present it to him. So if anybody sees Danny, tell him he's just come here and we'll give him his award. They really have. They've gone gung-ho. He's been working on both the training with ATSA. He's been really done a yeoman's task. The specification, access specifications, he's been working with us, done a great job, and they've done quite a bit of work. Georgia has done, I don't know, they've put out just a ton of projects of high friction surface treatment, really seeing the crash reduction. So the states in blue have kind of a lot of work in high friction surface treatment. The star indicates states that have an active program. It's kind of standard practice. And then you got the range of, you know, if they just tried it or if they're getting along in the use. But really blowing up. I think 2 people have talked to me, you know, Arizona said we're doing our first one this year, and New Jersey said we did our first one last year, and really exploring this. I think I ended right time for any questions. This is Rhode Island installation that I was at, demo project, Will. That was DBI did that automated installation there in Rhode Island. Thanks for the questions.